Ice, water, steam. You know them. They're all just H2O, the same exact molecule.
So how can just a little bit of heat totally change the way it behaves?
If you've ever felt lost in a bunch of gas laws and formulas, yeah, you're not alone.
But what if I told you it all comes down to one simple, single battle? It's a constant tug of war between stickiness, holding molecules together, and movement, pushing them apart.
Now, that stickiness comes from intermolecular forces, and they have different strengths.
When the stickiness wins the fight, boom, you get a solid, all the molecules are locked up tight.
And the movement side of things, that's kinetic energy, or as we usually call it, temperature.
Now, if movement wins, the molecules break free completely, and that, my friends, is a gas.
So what about a liquid? Well, that's what happens when the battle is a perfect draw. Okay, but get this whole battle idea, it also explains all those confusing gas laws.
You don't need to memorize a bunch of different rules. They all just roll into one master equation.
And here it is, the ideal gas law. It's basically the one equation to rule them all.
But why is it called ideal?
Well, it's because it makes two really big, simple assumptions.
It pretends molecules have no size and no stickiness. But in the real world, they absolutely do.
Real gases act pretty close to ideal when it's hot and the pressure is low, because they're far apart.
For real-world stuff, scientists just use a corrected formula that accounts for that size and stickiness. So, the main takeaway is this. Forget all the separate rules. Just remember the battle.
Which leaves us with a cool question. If temperature is just movement, what happens when it all stops?